Okay, so in this video we'll move on and talk about the next concept of integration, which is U-substitution. We have talked about this when we were doing P3, but now let's just do this once again. It should be a revision for you because we have done this when we were doing P3, but since you haven't revised P3 yet, I don't know if you have revised, but this is a fairly easy thing in P4 integration. As far as integration is concerned, U-substitution is one of the easy techniques. So let's directly jump onto the question. Let's do an example so that we get a better idea of how to do U-substitution. Okay, so let's look into this question. Whenever you have, before we look into this question, let's talk about it. For example, if you have to integrate a to b, then you have some function. Let's say this function x under root 2x plus 5. Limits are a to b and dx. And you have been given some u substitution, u equals to, let's say, 2x plus 5. So now this integral, which is in terms of x, has to be converted in terms of u. So there are three things which you have to take care of. The first thing is that you have to take care of this function, which is basically the function which you have to integrate. The first thing is you have to convert this into u. Convert. The next thing which you have to convert in terms of u is this derivative dx. It should go into some transformation and convert into du. Okay, and the third thing which you have to take care of are these. Which color should I choose? Are these limits? Yeah, these are the limits of x, right? These are the limits of x. You have to convert them into limits of u. So whenever u substitution is involved, you have to convert three things from x to u. The first is the function that you have to derivate. The second is the dx, you have to convert that into du. And the third are the limits. You have to convert the limits into limits which are in terms of x, or which are the values of x. You have to convert them into the values of u. Right now in this question we don't have limits, right? The question which is copied on the screen, it does not have limits. So we don't have to think much about limits right now. So let's talk about this question. The question is given as we have to integrate x under root 2x plus 5 dx, right? So, and they have also given us a substitution that use the substitution that u equals to 2x plus 5. If I put u equals to 2x plus 5, I get du over dx equals to 2, right? Okay. So now once I have du over dx equals to 2 and u equals to 2x plus 5, I can start to convert things from x to u. So we do integral. We write x under root 2x plus 5 is u. So we write this as u and then dx. Now from this differentiation, we know that we can write dx as what? 1 over 2 du equals to dx. Right? So I can further convert dx into du like this. 1x root u 1 over 2 du. This dot is not necessary. Okay. Now we have this x, which we also have to convert in u. So from the u substitution, we have u equals to 2x plus 5. So if I make x the subject, I get x equals to u minus 5 over 2. So finally this integral will become integral u minus 5 over 2 under root of u 1 over 2 d. Now if I simplify things and take the constant outside, I get 1 over 4 integral under root u times u minus 5, right? du. Okay. After this integration is very easy. You have 1 over 4 integral. This becomes u raised to the power of 3 by 2 minus 5 u raised to the power of half du. Integral of this is 1 over 4 u raised to the power of 5 by 2 divided by 5 by 2 minus 5 u raised to the power of 3 by 2 divided by 3 by 2, right? So this becomes 1 over 4 2 over 5 u raised to the power of 5 by 2 minus 10 over 3 u raised to the power of 3 by 2, and we have 1 over 4 outside. Okay. So this is no, this is not the final answer. We have to finally convert back this u and x as well, right? So what was u? U was 2x plus 5, right? Then if we convert back into x, we get the final answer as 1 over 4, 2 by 5, 2x plus 5 raised to the power of 5 by 2 minus 10 by 3, 2x plus 5 raised to the power of 3 by 2. This is my final answer, right? Using u substitution. Are you clear on this? Okay. So this is the u substitution of part A. In part B, they have given us another substitution, and they have said that integrate the same question using this other substitution, right? So once again, we have the question of we have to integrate x root 2x plus 5, but now the substitution is a bit different, right? And the substitution is u square equals to 2x plus 5. So let's do this. The question is same. We have to integrate x under root 2x plus 5 dx, but now the substitution is different. U square equals to 2x plus 5, right? Okay. So now what do we have to do? Can we write it like this? Okay. The first thing which we have to look into is, can we differentiate this? How do we differentiate this? This is u square. So to differentiate a function of y, whenever we differentiate a function of y, we write dy by dx with that. This is coming from the implicit differentiation. You need to remember that. You need to recall implicit differentiation as that. So this becomes 2u du over dx equals to 2, right? So if I take dx as a common, or this 2 and 2 would cancel out. So u times du equals to dx. This is the first substitution that we would need, right? Okay, let's move on to this and let's start substituting in the values. We don't know what to do with x right now. Under root of 2x plus 5 would be under root of u square, and dx is ut, right? So if we simplify this, will become xu square du. Now we also know that if I make x the subject, it would become u square minus 5 over 2. So x is basically u square minus 5 over 2. This is under root u square minus 5 over 2 u square d, right? So this becomes 1 over 2 goes out. We get u4 minus 5u square du, right? If we integrate this, 1 over 2 u5 over 5 minus 5u cube over 3, right? Now substitute back the values. So if u square is 2x plus 5, u would be under root 2x plus 5, right? So now if we start substituting back the values, it becomes 1 over 2 under root 2x plus 5 raised to the power of 5 minus 5 over 3 under root 2x plus 5 raised to the power of 3. Now this is a homework for you to show that this result from the first substitution, substituting u as under root 2x plus 5, and this result by substituting u Sorry, I make a bit of an error. This is not an error. Here we substituted u equals to 2x plus 5. Here we had substituted u square equals to 2x plus 5. Now the substitution should not change the answer, right? And we have plus c as well. We have plus c there as well. The substitution should not change your answers. So what you have to do is you have to show that these two answers are basically equal, and it is a very easy thing to show. Okay, so now let's move on and let's give you some okay, you have to do these questions right now. Pause the video and try to do these questions. Yeah, right, you need to pause the video and try to do this question. Let me just do part B with you. Let's do part B, and then you have to do the rest yourself. So we have to integrate 1 plus sine x over cos x dx, and the substitution given to you is that u equals to sine x. Right? So if u equals to sine x, du equals to cos x du over dx. So basically du equals to cos x dx. That's the substitution that you have. Okay, now start plugging in the values. So we have integral 1 plus sine x becomes 1 plus u divided by cos x, and dx is can be replaced by what? Dx. Okay, we need to simplify this further. 1 over cos x du equals to dx, right? So dx can be replaced by 1 over cos x du. So now you have what do you have? You have this integral 1 plus u divided by cos square x d. Now you have to apply certain identities in question. A trig whenever a trig is involved in any question of integration or differentiation, you have to recall all the identities of trigs. So cos square x is 1 minus sine square x. So this becomes under root 1 plus u divided by 1 minus sine square x dx. So this becomes integral 1 plus u divided by 1 minus u square, right? Du. So this becomes integral 1 plus u over 1 minus u, 1 plus u du. 1 plus u, 1 plus u cancels out. So all that you're left with is this integral 1 over 1 minus u du, right? And the integral of this is negative ln 1 minus u, right? So if you look into the denominator, 1 minus u. If you differentiate 1 minus u, you get minus 1. But since you have 1 in the numerator, you put minus outside, you put minus inside. So this becomes u prime over u, right? And integral of u prime over u is ln u. And we have negative outside as well, so this becomes negative ln 1 minus u. But since u is what? U was sine x. So 1 minus sine x plus c. This is our final answer for part B. So now you have to pause this video right now and you have to do A, B, C, D, E, F, right? And check your answers from the book exercise 6C. Okay, let's do one question. Let's move and let's do one question with limits, okay? So that we know how to treat limits as well. This is also a fairly easy task to do, but let's do this. Okay, let's do this question. The question says use integration by substitution to evaluate these. Okay. So now in part A, let's take the substitution as u equals to x plus 1, right? So du over dx equals to 1. This gives du equals to dx. So integral becomes 0 to 2. Okay, if we make x a subject, we get u minus 1, right? So we get u minus 1 and uq du, right? We have 0 to 2 u4 minus uq du. Now there's one error in this. The error or one thing which we haven't corrected yet. It is that we have converted the whole function and the differential in terms of u, but we are yet to convert these limits in terms of u, because when these limits were given to you in the question, they were in form of x, right? The limits, if the question is in x, the limits are also in x. So now you also have to convert the limits in u. So we know that u equals to x plus 1, right? So when x is 0, here the lower limit, when x is 0, so u is 1, and when x is 2, u is 2 plus 1, putting value here, u equals to 3. So finally we get integral 1 to 3 u4 minus uq du. If we integrate this, we get u5 over 5 minus u4 over 4, and limits are 1 to 3. Now you don't have to convert this back into x, because now you have to plug in the limits and you have to find the constant answer, right? You have to find a number, not a function, right? So you don't have to convert this back in terms of x. You can just plug in the limits of u in this function. That's the whole point. That's why we converted limits from x to u. So we get whatever we get. I'm not solving this any further, right? You get the general idea. Let's talk about b then. In b, we can take substitution as u equals to 1 plus sine x, right? So if we take u equals to 1 plus sine x, du becomes cos x, du over dx is cos x dx, cos x, and then we can say du equals to cos x dx, right? Okay. When doing by use of substitution, we also have to be very vigilant to see any pattern emerging in the question, right? For example, in this question, a pattern will emerge, and we look for that. So we have 0 to pi by 2. Root 1 plus sine x can be written as root u, and then we left with cos x dx. Now if we observe this a bit closely, cos x dx is basically du, right? So what we can directly substitute cos x dx as du under root u du. Now we also have to convert these limits in terms of u. So here we have u equals to 1 plus sine x, right? So when x equals to 0, u equals to 1 plus sine of 0, which is basically 1. When x equals to pi by 2, we have u equals to 1 plus sine of pi by 2, which is basically 2, right? So finally we'll get 1 to 2 root u du. Now when we integrate this we get u raised to the power of 3 by 2 divided by 3 by 2, and limits are 1 to 2. When we put 2 times 2, 3 by 2 divided by 3, minus 2 times 1, 3 by 2 divided by 3. Right? You can simplify this further and get the final answer. I hope you get the general idea of what we have to do in U-substitution. Now you have to do exercise 6C. So as a homework you have 3 things to do: 6A, 6B, and 6C. Right? Okay, take care of this.